All right, so a conical cup is 4 centimeter across and 6 centimeter deep. So this is the size of the cone. So the cone is 4 centimeter across and okay, and 6 centimeter height. Okay, I'm putting the variable because the size of the cone will not changing, of the cup will not changing. And then water leak out at the bottom of at the rate. So the water is leaking out at the bottom. So water is the volume. So I label that at the volume. Leak mean the volume will be decreased at the rate 2 centimeter per second. So dV over dt will be negative 2 centimeter cube per second. Now, we're interesting to know how fast the water level drop when the height is of the water is 3 centimeter. So we want to know how fast, which is the height. The water level is the height of the water, right? How fast the water level drop when the height is 3 centimeter. So it's mean dH over dt at h is equal to 3. All right, so we're gonna get the, and also what else will be changing when the height change, the volume change? The radius of the water is also changing. So because when the water dropping down at this level, the radius is also getting smaller, right? So the radius is also changing. So we need to get two formula. One is for the volume and one is for the radius. When we relate the radius with h. Okay, so now let's do the volume. The volume of the conical is 4/3. 1/3 pi r square h. So the volume is 1/3 pi r square h. And then we also have the radius and the height is changing. So we can also write the formula that have the radius and the height that is related. So we have we can use the facts that these can be divided up into the right angle if I draw it like this. Then the half of this, the radius, this is the diameter of the top of the cup, right? Then half of this is going to be 2. So isn't that this would be 2? And my radius is any point. And this is going to be my h. The whole thing will be 6 centimeter. So because the triangle, the smaller triangle, is actually similar to the big triangle. So we can use the proportion of the similar triangle, which is the radius over 2. The ratio of this over this is same as the ratio of the height over the height. Okay. So because we only care about what is the rate, the rate of change of the height, we can also consider isolate the radius in terms of the height. Then my radius is 2/6 times height, right? Because you can multiply 2 on both sides, and that would be 1/3 of the height. So at that time, when we have radius is 1/3 of the height, I can substitute the radius into the equation, which is 1/3 pi of 1/3 h squared times the height. So this will give us 1/3 pi of 1/9 h squared times x. Rewrite it one more time. We have the volume is 1/27. Pi over 27 times x cubed. And now we can find the take the derivative on both sides. So dV over dt will be pi over 27 times, bring down the 3, we have 3h squared times dx over dt. Okay, and then we're putting everything that we have. We have the volume is -2, which is the rate of change of the volume is -2. So this will give us -2 equal I can simplify the value as well. Pi over 9. H is 3, so it's going to be 3 squared times dx over dt. So it looks like 3 squared is 9. 9 and 9 could be canceled out. So that will give you -2 over pi equal dx over dt. Okay, so the water level is dropping at the rate of 2 over pi centimeter per second.